The last thing, how about I have both nonlinear equality equation and the inequality constraints. So if you have both of them, the best way you have those mixed, then you change all into the non-linear inequality. You can put it together. So for the linear one, I talked this a little bit. I'll let you read it by yourself. Just look at one more example. In that example, I tried to solve the second example we did. That's the second example. You can look about it. See, here's a straight line. No, this is the third example, actually. And yeah, we used both for the second and the third. So that's the objective function. And this is a nonlinear inequality constraint and the nonlinear equality constraint. You write this into the system C. No, this is the equality. That's the inequality. Inequality is always less than or equal than 0. That's not the same problem. Actually, we changed. The equality is equal than 0. So in this case, we need to write into a confound equation for the nonlinear constraints in this form. And all you need to write these two differently. That's the constraint. Because in this, you have two return vectors. Let's look at the form again. See, these two, one, the C is in equation. C equals the equation. And then you need to change, this is the same, but the other one need to move to the equation. That's how different from this one. So, okay. Now once you write down this, everything else is the same, except your options. You put this algorithm active set. I honest with you, I don't know what that means, but you follow what they said. And then maybe we'll do a little bit active search. It's all about the search of the solution space. Now what you added is the same thing, but this function is different, and you need to set up an option and start with whatever reasonable guess to solve the problem. So once you solve it, they give you the solution. Whoa, it checked all 21 functions. In that, how can you get this many? Well, think about the 6 parameters. Take the partial derivative of 6 functions. Then you get the 6 equations. Add the original one. 21 is not a big number for computer. But anyway, you get the solution. You get the maximum. What's next? Next, you need to check your constraint. When you put this check, the C, very good, that's less than 0. The equation, that's 6.3 times 10 to the negative 9, of course, that equals 0 numerically. So we'll satisfy both the equation, so you get the right solution. So after you finish your solution, don't just take it. You need to check the C and the C equation for this to return value. This return, if it's wrong, give me an example. If you get this C equal 9.6, for example, that's obviously wrong because the C must be less than 0. Well, there's a lot of information. If that's not good, hard to remember, well, I hope you can get the toolbox called the solver. that solver has a user interface. And the user interface will help you just to fill in. You don't need to write your own function. You just fill in what is your objective function and what's your constraint equation, what's your constraint in equation, and then you run it for you. Oh, what is your starting point? So what I need to let you be careful is that, again, the canonical form. And you need to keep a few things in mind. They're always very strict. First, you minimize f. Second, all in equation must be like this. Third, you need to separate linear and the non-linear constraints. We did not talk linear this time, but we talked it before in the last lesson, and you have it in your textbook. So once you know how to write into the canonical form, you're good to use the f mini con function. I call it f mini con, minimize with constraints. So now, as I showed you earlier, with this powerful tool, big concept, you are ready to do research in a lot of real world optimization problem. The only thing difference is the number of variables, number of equations will be different. Could be much bigger calculation. But you are going to test the MATLAB. They did a great job, but not always work. Sometimes you need to learn when your solution is wrong. How do you check it? All right, and this lesson finished the second unit. The last unit, the next 3 lessons, we're going to focus on the goal, the major purpose of this module is the Kalman filter and how to use it to solve the GPS problem. That's the most beautiful, powerful application of optimization. Well, I want to let you know, be prepared. The notation will be very complicated. Don't be scared though. We'll see you next time. Thank you.